Hello, fellow plantigrades. Now, if you're wondering what that word means, you either weren't paying attention in class, or you might have forgotten. This word refers to one of the three important foot postures. Through evolution and specialization of specific species, these types of foot postures are important to answer our group's intriguing hypothesis.
If foot posture is essential to locomotion, then mammalia of differing specialization do compare in foot posture.
Citali, Alex, Maddie,
and Tanner.
We'll be going over each foot posture and how its structure affects the mammal's locomotion. Sources will be mentioned throughout the video and cited at the end. Now, before we get started, this video is sponsored by Raid Shadow Legends. Nah, I'm just kidding.
Plantigrades are animals that walk with their tarsals, metatarsals, and phalanges on the floor. This is a primitive foot posture that has two segments that separate their body from the ground. One example of plantigrade mammals are primates. Humans are a form of primate that happened to deviate from the standard trade-off of specialization of the plantigrade foot posture. According to researchers Weber and Reichland, it is apparent that humans have specialized adaptations such as the heel strike gait to maintain endurance. This helps with terrestrial running, self-defense, and paying tuition. As humans, we need to be able to travel long distances without getting tired, which is what the heel strike gait helps us do. The heel strike gait describes the action in which there is no midfoot contact. The heel of the foot touches the ground first on the calcaneal tuberosity. The next point of contact is the ball of the foot, and then the movement is completed by a rolling motion of the toes. Another example of a plantigrade mammal is the order Rodentia, which includes squirrels. Looking at the video in front of you, the squirrel is using their forelimbs and hind limbs to climb trees. They have the strength to maneuver vertical slopes, and they have ability and flexibility to control their digits of both their forelimbs and hind limbs. And this allows them to establish their homes in trees, as they do not need to travel as far, nor as much as humans do. Because their limbs have shorter outarms, that gives them a greater output force according to the relationship of the output force equation. Because of this, their limbs are better adapted to resist the complications other animals usually face when climbing trees, but at the cost of moving at a slower pace.
Digitigrade animals walk on their toes without their heels coming in contact with the ground. The limb segmentation of this posture means that the phalanges are on the floor while the metatarsals and tarsals comprise the vertical segments of the foot. Examples of digitigrade animals are members of the carnivora class, including dogs and cats. An important aspect of different limb structures is that they are adapted for different functions. Dogs utilize their digitigrade posture to reach high running speeds and for increased flexibility, such as the ability to scratch themselves. The dogs are also able to utilize their flexibility to perform tricks that you can see in this adorable video. The digitigrade posture is derived from the ancestral plantigrade posture and represents a compromise between the other postures and the functions afforded to each one. The additional segments seen in animals with digitigrade posture gives the animals mild cursorial adaptations, such as increased speed and reduced force. According to Carano's research article, findings also showed that many digitigrade animals present cursorial adaptations, such as the metatarsals of digitigrade animals being longer. Lengthened metatarsals, as well as other limb elements, allow for increased stride length, thus increased speed. However, this does come at the expense of force. Typically, cursorial specializations come with a trade-off of reduced function. However, digitigrade animals like the cat retain functional digits. This type of posture is the intermediate, falling between plantigrade and unguligrade postures, considering the anatomical structure.
Unguligrade is the type of foot posture where animals walk on their toes or hooves and is derived from the ancestral plantigrade posture. Ungulates are under the class Mammalia and can be divided into two orders. One order is Perissodactyla or odd-toed. Horses fall under the order Perissodactyla. They walk on two toes with little contact with the ground. This minimal contact between the hooves and the ground minimize friction and allow for them to achieve high speeds. They also have additional segments that aid in distal lightning and allow them to specialize in being a runner. Looking here at the horse's limbs, their muscles are concentrated at the most proximal portion of the limb in the first two segments, which Dr. Resnick explains during the pendulum example, aids in distal lightning. Another form of unguligrade is Artiodactyla or even-toed. Cows are a part of the order Artiodactyla and walk on four toes. They are not specialized for running like horses. They instead can be seen as generalists, an animal who is not specialized in being a runner nor a digger. Henry here is a pig and is in the order Artiodactyla. Similar to cows, his kind are not specialized for running. If you compare a pig's appendages to a horse, you can see there is an extreme difference between the horse's elongated limbs and the pig's being short and stout.
Goats are part of the order Artiodactyla. Like the others, goats are even-toed and maintain distal lightening of the limbs. Now, if it wasn't apparent enough, this evolutionary development does not only give a significant trade-off in the comparison to its flexible counterpart, but Eugene here looks absolutely fantastic.
Eugene, you got nice toes, bro. Yeah, nice toes.
To restate the hypothesis, if foot posture is essential to locomotion, then mammalia of differing specialization do compare in foot posture. Throughout the data collected and sources cited, it is clear that the animal's lifestyle is essential to having the best and most adaptive locomotion. I am the one. The hypothesis is proven true. Squirrels need to climb trees, cats are capable to hunt, but mostly be cute, and horses to maintain high speeds. Foot posture plays a vital role in allowing these animals to perform what is essential for their specialization. As promised, the following is our works cited section.
Bye, everyone. I'll remember you all in therapy.